And piecewise is just kind of an extension in some ways of our step functions, except now the graphs aren't necessarily going to look like steps. They can look like lines going in all kinds of different directions, but there's still application work to them. So, again, piecewise, we've got to get used to a couple of things first that are going to help us when we actually start doing the graphing. And the first is evaluating, which is a nice review because we had a couple issues with this on the prior quizzes in here. So evaluate f of x, remember that's just y equals in fancy speak. So you have these two expressions. And you have these two if statements next to it. Okay? So here's the deal with the if statements. These right here are going to tell me which function to substitute into. So here's the thing. For every single value that I can plug in for x, it's only going to work for one of these. If it's less than or equal to 4, we're going to plug it into the top one. If it's greater than 4, we're going to plug it into the bottom one. We are not doing it for both. You don't get to kind of throw them both out there and hope one works. So, all we really have to do on these is be like, okay, so 5.2. Well, let's see, is 5.2 less than or equal to 4? No. Is 5.2 greater than 4? Yes. So we're going to take, and I'm going to color code these so we can kind of speak of them as we go. So the teal one is true for this one. So we're going to take that 2 times x plus 7, but we're going to replace the x with the 5.2 because that is greater than 4. I'm even going to write that up here just so I can kind of get myself thinking about that a little. Plug that into the calculator. Get my solution. So when we're evaluating, it's always the same 2 steps. Check to see which one's true. Is negative 1/3 less than or equal to 4? Yeah. Because negative is always less than positive. So we're going to be plugging into the red one. That goes in for my x. And again, here you can do it in your head. You can go straight in and type it in the calculator. It doesn't matter. You don't get extra points for doing it one way over the other. Solution. And so, this is the one to be careful on, though. Because you look and you're like, okay, well, 4 isn't less than 4. Oh, but that little line is less than or equal to 4. 4 is less than or equal to 4. So we come over here and we plug the 4 in for the x. The reason understanding that piece is important is we're not, when we graph these, we're not just graphing lines, we're graphing parts of lines, specific parts of lines. And we've got to be able to understand when lines start and stop. What values can I use? And so one more little piece of this is understanding these 3 different functions. Notice they all have different letters in front to label them. So when you're looking at these, the number inside the parentheses is still just the x value that you're substituting. This just tells me which function am I looking at. So, for instance, on this first one, f of 2. Okay, I'm looking at the f function. First job, always to look at the if statements. So I'm looking at 2. Is 2 less than or equal to 0? No. Is 2 greater than 0? Yes. Well, Hardy, there's nowhere to plug a number. It just says 2. Okay, then just put 2. Just like if we're doing number 7, I'm going to be back to this one. I see it's the f function, so I'm back over here. What happens when x is 0? Is x less than or equal to 0? Yes. So you're saying if I get f, the answer is always going to be 3 or 2 no matter what? No matter what. Get two-piece process. G, okay. Here's my ifs that I'm looking at. G of 7. Is 7 less than or equal to 3? Nope. Is 7 greater than 3? Yes. There's the expression that I'm plugging into to get an answer. Let's stick with G. -1. Is -1 less than or equal to 3? Yep. There's the expression I'm plugging in for and getting an answer out. So letter tells me which function. Number inside tells me which expression to plug into. So here, okay, here's H. -4. Is -4 less than or equal to -2? Yep. We're plugging in here. Half of -4 is -2. 4 is -6. So the function tells me what pair of expressions to look at. The number inside tells me which one I'm plugging into. But you've got to make a decision because there's always going to be one every time. Any issues there? We're about ready to hit the main event of the day. This is going quick. Okay. That's one way we're going to be able to make these graphs that are coming. But I'm going to show you, I always like to show you at least a second way to things if I can. So, okay. One thing I would suggest that you do on these, if you don't normally, use a pencil, at least at the start. I'm going to show you a couple of options, but pencils are probably going to be more friendly for this. So, graph following functions, find the domain and range. Okay. First things first. I look at my first one here and I go, okay, so 1/2 x. Let's say I was going to graph this like a normal line. So if I was looking at that, my y-intercept, of course, would be 0. Lightly with your pencil, hopefully we have an eraser still, even though I'm going to show you some options. Okay, so there's my y-intercept. My slope is 1/2, so I'm going to go up 1 and right 2. So I'm just making dots. I'm going to make as many as I can on my graph, both directions. So if I run out of room to the right, I can also go down 1 and left 2. I can do opposites of both of these. So I get all those dots made. We're not going to connect them yet, though, because the only part I want the line is going to start where x equals 1, not 0. You're like, well, wait a minute. If x starts at 1, like there's nothing here, Hardy. Like literally nothing here. This is where, again, we're going to use our best guessing skills here. If I were to put a line through here, my 1 value would probably be about here. I want the points where x is less than 1. Open circle, because I'm not including 1. Less than goes to the left. I don't want the rest of this. Only that piece. So you kind of see why the pencil can come in handy here. And so I do the same thing for the second one. And again, pay close attention when there's negatives and stuff here. That matters. My y-intercept is at 3. My slope is negative 1 over 1. So down 1, right 1. Again, I'm kind of being light with my dots because some of them are going to go bye-bye here in a minute. So down and right, my opposite would be up and left, up and left. So I'd make my line with dots first, then leave it be. The line is still starting at 1. Now this time, hey, I actually got the dot at 1. That one was open because it was just less than. This one, because of the or equal to, is closed. So I'm going to make that really big and dark. And greater than means I'm going to connect the dots that are to the right of that. Erase the others. Okay. To me, and again, everybody's different, that's going to be the easiest way to do these. We're not going to have gaps, just like we did with the step functions. This is going forever to negative infinity, and I come over, and when I get to the circle, whoop, I get beamed up, and then I keep right on going. So let's chat domain and range for a minute. I'm going to show you another way to do this if you're like, not so sure about that, Hardy. Your domain on these will be going forever. Because anywhere there's a hole, there's going to be another filled in dot, and it's just going to keep going. Okay? You can write it this way. You can write it as all reals. I don't care. I'll take either. My range, however, doesn't go infinitely. Because remember, that's my y values from bottom to top. It goes down forever. So negative infinity, okay. But this is as high as it goes as far as y goes. So it only goes, in this case, as high as 2. Could that be all reals at times? It can be. So let's just say, for instance, you and graphing lines aren't friends. Okay, that can happen sometimes. So if that's true, here's your backup plan. So if I've got 1/2 x, you could use 0.5 as well. I'm going to pull up my chart. And since the only values I want are when x is less than 1, I would go to 1. There's my y value, 0.5. So we did a pretty good job when we even guesstimated before. And then what I would do is I would start taking every point before that. So 0, 0. I'll just even use whole numbers. -2, -1. -4, -2. And I can connect the dots. The chart will work. I can come back here and do that for the second one. -x plus 3. Just pull the chart. Again, we're starting at 1 though. Don't start at 0. Don't start at 3. 1, 2. Filled in dot. And all the values to the right that get greater than. 2, 1. 3, 0. 4, -1. Connect dots. You will always have one of your segments, one of your rays going to the left and one going to the right. They will never go the same direction. They're not both going right or both going left. It's going to be continuous. And so when you're doing these, the critical part is going to be, that through. So let me do one more where we kind of play it both ways. And then we'll kind of see where we're at. So this time, your lines both start at x equals 0. This always tells you where your open circle and your closed circle are going to be, your starting point. If some of you are good enough at this, you can eyeball it, just start at the 1 point and go. That's cool. But if not, that's okay. So 3, my slope is 1. Number 1. Up and right, down and left. Holy, get it dotted. We start at x equals 0. Okay, so there is my point when x equals 0. It's less than, to the left, less than or equal to. So that stays as a filled in dot. And we want all the points to the left. So connect those. Don't want you guys. We're done there. Do the same thing here. My y-intercept is 0 if I don't see one. We're going up 2 and right 1, up 2 and right 1. Or instead of up and right, down and left, down and left. Again, starting at 0, open circle. So let me make that open. Greater than goes to the right. So the points there are getting greater. No gaps. Start at my negative infinity. I'm following. Okay. There's my closed circle, so I still have a value here, and then it just starts up again. Domain, easiest part of the question on all of these, because your domain is always going to be infinite. It's going to be all reals. Your range this time. Arrow down goes to negative infinity. Arrow up goes to positive infinity. So if the arrows are going opposite directions, everything is infinite. If they both go the same direction, then we got to play with range a little bit and see how that works. And again, just as a real quick show or a quick reminder here, and again, I put these things up and record them here, so if you need to check something later, you can. I go to 0 again. There's my 0, 3. I know it's a closed dot, and I know I'm going with lesser values. Negative 1, 2, negative 2, 1, negative 3, 0. If I need some help on the other one, I start at 0 again, 0, 0, there we go. Follow the arrow, we're going to the right, we're getting greater, 1, 2, 2, 4, and on, and on, and on. So, whether we're line graphing experts or not, really doesn't matter. It's just getting used to some of these. Now, this one gets a little more interesting. Because now you're like, okay, so 5, if x is less than or equal to negative 1. Okay, so we know y equals 5 is a horizontal line, hopefully. So if we start where x is negative 1, we go to where y is 5, close dot, going to the left. Horizontal line, starting at x equals negative 1, and going to the left. We've got lots of little pieces to play with. We play with the middle one. We go, okay, this is a little more normal. There's my y-intercept. My slope is 2 over 1. So up 2 and right 1, up 2 and right 1, down 2, left 1, down 2, left 1. I still would very much encourage you to plot out the whole line before you try to do pieces. Especially here, this is going to get interesting again. Ooh, we got an in-between this time. We're starting at negative 1. Okay, so here's x equals negative 1. There's my point. That's going to be an open circle because it just has no or equal to. Then I go to 2. Okay, x equals 2. Okay, I got a point there. Again, no line underneath. That's going to be open. And it's in between. So it's just connect the dots. No arrows. Okay, we're not going forever in a direction. We have 2 definitive endpoints. Hence the open circles. And then we got one more. Be careful. Not in the normal order that we like. I actually like to rewrite these and put them in the correct order of slope-intercept just so I don't do something silly. My y-intercept is at 4. My slope is -1. Down 1, right 1, down 1, right 1, down, right, down, right, down, right. We're starting this one. Wow, they're even moving these around now. We start this one at x equals 2. Okay, there's the point at x equals 2. It's or equal to. Closed end dot. Greater than. We're connecting the points to the right. I don't want any of the rest. So I follow this. Again, if I've done it correctly, there will be no gaps anywhere. So I start at the left with that forever arrow, and I'm going to the right. Okay, there's my closed dot. Where do I go? Down to where this open one is. But we're still covered at -1. Follow that to the right. Oh, now I got an open circle problem. Oh, wait. If I drop down, it's still filled in. I still have a value. And I'm off forever to the right. No gaps. No blanks. No open spaces when we're doing these. Because the domain is always infinite. Always, 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 always. You don't even have to look at the graph. You see piecewise function, your domain is this. It's like the free square question. Now range gets a little more interesting. Because here, I see it's going down forever. I'm like, okay. We're not going up forever. Well, there's an arrow here, yeah, but it's going sideways. It's going horizontally at 5. Be careful. We can kind of go back and forth with those. Okay. I think it's worthy to play with one more of these because this is a little kooky. Here? Okay. Because y equals 5 would be a horizontal line at 5.
Yeah.
But I only want the part of it where the x value is less than or equal to -1. So it's got to start there. Yeah, little detail things on this are quite huge. So luckily for us, at least on this last one, these are going to be similar. So you're like, all right, one more time. I thought about freeze framing this, but I don't know. Y-intercept. Slope's -3/1. Watch for my negatives. They can be a little light sometimes. So there's my line y equals -3x. But I only want it starting at -1. Okay, I got that one. And I want it going to the left. So we only got 1 point to connect to, but that's okay. These still work just like they did before. If you wanted to go to the graphing calculator, just use the points that are involved over here to the right. It'll absolutely work. I'll try to pop that up here at the end. Okay, plain old X. Okay, start at 0, 0, up 1 and right 1. Lots of things to dot. but I only want a certain number of them. Look again, and I go, okay, just less than on both of these, so we're doing circles, open, at -1 and 2. So at -1, erase that and make it better. -1 and x equals 2, right there. In between. Open, open. And then another horizontal. Y equals 4. When x is greater than or equal to 2. So again, x equals 4 would be along here. But I only want it starting at 2 and going to the right. Now, this one, did I just make a liar out of myself? Let me look. No, I did not. Okay. Our domain, we don't even have to mention because it's the same every time. That, even though it's going up, is still slightly going to the left. So we are going forever left, forever right. Now, range value. We're going up forever. Okay, that's cool. This is not telling me my lowest y point. So now this gets interesting. So down here at the bottom, my y value is -1, but it's an open circle. So I've got to make sure that when I do my range, I do a parenthesis on that because it's open and not closed. Little details that we're trying to make work. Again, graphing line's not your friend. Go to the calculator, use the chart with these restrictions. But other than that, we kind of have some idea on where the holes and things are going to be. And as I tend to do every time, we got to be able to go both directions. You get the piecewise function, I give you the graph. Now let's go the other way. You get the graph, give me the piecewise function. So, here's the way I like to build them. I'm going to have two equations. I see two lines here. The first thing I always do is focus where my lines are starting. I want to put my if statements first. So here, for my top one, I notice we're starting at -2. It's a closed circle, and it's to the right. So I took the closed circle to get the or equal to, the direction to get the arrow, and the number from here. And so I'm going to do the same thing on this one. We're still at -2, but this one is an open circle, so it's not going to be or equal to, and the line is going to the left. So once I have that, now all I have to do is I'm doing an equation in slope-intercept form. So I'm like, this one I know the y-intercept, it's at 3. And what's my slope? I don't know, up 1 over 2 maybe? Up 1 over 2. So 1/2 x. Now, this one's a little more interesting. I can figure out down 1, left 1, down 1, left 1. So my slope will actually be +1. So I could just put x. I can put 1x. It doesn't hurt. Well, where's this come from? We have to extend the line. So if I know my slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, you can extend. I mean, I'm not going to draw more of the line because that would be incorrect. But that's how I can extend to see where my intercept is going to be. I may have to extend my line some. And then I can go back and kind of check to see where those would be. So you got to be a little bit of a detective on this. It's not going to be the easiest thing sometimes, but it's workable. And so the good part about this stuff is these two different activities kind of support each other in that we did that stuff before and we're trying to do open dot, close dot, where does it go? So now when this last one shows up, and luckily for us the lesson tomorrow is much shorter than this. I do appreciate your patience here on this. But one more time, because I think it gives us a very good connection on how this works. So I look and I'm like, all right, so let's see. I got this one over here that's starting at -2, open circle and going to the left. So I got that. Then I got this stuff in the middle, closed on both. Whenever you're doing a compound inequality, we both just put both arrows to the left, because then I can go from least to greatest. And then I got one last one up here, starting at 3. And we're going to the right, and it's open. If you make your if statements first, now when I go to get my other equations, this shouldn't be anything too bad. So I look, and I'm like, all right. So this guy looks like we're one and left, one down and left. So it looks like here my slope is going to be 1, or 1 over 1. So up 1, right 1, up 1, right 1. There's my y-intercept. Here we got a flat line. We're horizontal at y equals -2. So we just put in the -2. Now this last one's a little more interesting, because you're like, okay, so down 2 and right 1, down 2 and right 1. I know it's -2x. How the heck am I going to figure this out? Well, we're going to have to get a little creative here. So I look and I'm like, all right, so I got to go 1, 2, 3 more over. So I got to get to x, I got to get to 2, I got to get to 1, I got to get to 0. So let's get creative. So I'm going up 2 and left 1. So if I do that, if I go up 2 and left 1, that's going to put me to y of 7. And then I go up 2 and I go left 1. And I go up 2 and I go left 1. Sometimes we're going to have to extend our brains a little bit here to work those out. And I've got it. So, critical stuff here when you're looking. Now, this is going to seem like this homework is ridiculous, but when you think about that you're matching and stuff, it's not going to be as bad as you think. Especially when we're going to have work time more tomorrow and then in midweek too. The practice is going to start on 9 and look like it goes forever. Because you're flipping, you're like, okay, oh my gosh, Hardy, 10. Then you're flipping, 11. Hardy, this goes all the way to page 12. Well, I mean, there's like one question on the top. It's mainly the answers on page 12. But again, if you look at it odds-wise, quick substitution problems, okay. How the heck do I do this? So all these graphs are here. So how would this run? So let's say, I'll even do one with you on this. So let's say we're at 12. First hint, always check the if statements, because check this out. There's only 2 of these. That starts at 1, that starts at -1, 1, -1. Okay, I already know before I even start it has to be one of these 2. Because these are the only ones that start at 0. So then I look, hey, these both have y-intercepts at 4, and so does this one. I'm just testing your logic, to be honest, on this whole section. Because all the graphs are there. You just have to find now, hey, intercept at 3, intercept at 4, they start at 0. Oh, this is F. Okay. Don't make it harder than it needs to be. Now, you will have some areas where you're actually doing your graphing in the domain and range. But again, you're only doing the odds at the start to double check you've got examples that are working. You can do this. You can get this done. Especially if you're heading to advisory right now. I mean, hey,